I welcome to all our third session of Asia series, webinar series. So thank you for everyone for joining us with this session. And so far we have done two sessions up to now. So first one was introduction to Asia. Second one was application to the application of Asia. So in the previous session, we went through the application of Asia as well and various features in Azure services. So if you have any missed the session, you can always go to our playlist on YouTube and check it out. And we are planning to do more session apart from these and apart from this session for this webinar series. We have planned a Azure management tool and security solution session next week. And apart from that, Azure storage services and Azure DevOps Part 1, Azure DevOps Part 2, and Azure Container App. Those are the session we have planned. And so hoping that all of you will continue with us until the last session so that you will get a comprehensive knowledge on Azure services. If you have any question today, you can drop in the chat, and at the end of the session, we will be having a Q&A to answer all your questions. So the today speaker is Nishara Ramasinghe. She is a software engineer at 99X with over 2+ years of experience in full stack development. She has been able to handle projects from conception and development to deployments using Azure services. I would like to warmly welcome Nishara to continue the session. Nishara, over to you.
Yeah, okay. So thanks, Rashan. So hope I'm audible to you all.
Yeah.
Okay. So hi, I'm Nishara Ramasinghe and a software engineer from 99X. So today with our third episode, I'm going to present you about Azure Durable Functions. So yeah, let's start. So from this webinar, so we are planning to give a overview about Azure Functions and then our main topic, which is about Azure Durable Functions. So under that, we are planning to cover the structure of durable functions, patterns in the durable functions, and best practices. And in the later part, planning to discuss about pros and cons of the durable functions, and also planning to do a small demo where you can demonstrate about developing, testing, publishing, and deploying these Azure durable functions. Uh, yeah. So, what is Azure Function? So, Azure Function is a serverless solution that allows you to write less code, maintain less infrastructure, and save on cost. So, Azure keeps the infrastructure up to date and keep our application running, which means we can quickly develop and deploy small pieces of code in the Azure cloud environment. So with the Azure functions, we can focus more on the code instead of worrying about spending time on deploying and maintaining servers. So Azure functions are serverless solution in the Azure. While so if you have any cloud experience with the AWS, this is quite similar to the AWS Lambda. So Azure functions allow you to implement your system's logic in readily available blocks of code. So these blocks of codes are called functions. So different functions can run anytime. So you need to respond to the critical events. So when the request count increase, Azure functions meet the demand with as many resources and function instances as necessary, but only while we need it. So as requests fall, any extra resources and application instances drop off automatically. So that's why Azure Functions provides compute on demand. So Azure Functions is a serverless evolution of Azure Web Jobs. while the durable function is the serverless evolution of the durable task framework. So let's move into our main topic of the day. So it's durable functions. Basically, durable functions is an extension of Azure Functions and Azure Web Jobs, so that let you write stateful functions in a serverless compute environment, and it built on top of the uh, durable task framework. It manages state checkpoints and restarts as required, so which help us operate long-lasting stateful operations in the Azure environment. With the help of durable functions, we can implement a state in the Azure Functions stateless pattern. So what is this stateful function? Stateful function is an API that simplifies the building of distributed stateful applications with a runtime built for serverless architecture. So because durable functions let you define the stateful workflow by writing orchestrator function and activity functions, we are knowing that durable functions are stateful functions. So basic durable function app consists of three functions. The number one is orchestrator function. Then the number two is a activity function, and the last one is client function. So normally, when we await durable orchestrator context, it write to a history table and exit the function. So when the output is ready, it rerun the function to the point of the await and inject the value in. So I think it's quite complex. So let's uh, try to understand with this diagram. So normally that the Azure function is always considered as a software switch. So since it take data from input parameters, then it process the data and then it performs the appropriate action. But when it comes to the durable functions, instead of using a single function as a switch, it always take a series of functions and act as a single unit, which means that we are taking a series of function and it is a one block, and then with that we build the workflow to manage actions and handling wait pausing the function for the final decisions. So in this diagram, you can see this starter is like an entry, then the orchestrator. So there we can define here. It's like the where the workflow is defined, and with the activity functions, we are performing the activities related to our our scenario. So when the workflow is broken, durable functions holds its state externally, so that once the workflow is assigned, again started, it can pick up the state value and carry on the process. So now I think you can understand where that when we await durable orchestrator context, it writes to history table and then exit the function. And when the output is ready, it rerun the function to the point of the await and the inject the values in. So the first function I'm going to explain is about orchestrator functions. So an orchestrator function has an one role only to define. It's like here that I use the image. It's like a manager kind. So it has only one role. And so inside this orchestrator, it defines the workflow. So inside that workflow, then we can orchestrate to the other functions. For we can within this orchestrator function, we can coordinate other activity functions. But inside the orchestrators, normally we don't perform any actions itself. So like calling APIs or writing to databases. So uh, we don't do normally those processes inside the orchestrator. So then during this concept, so where we gonna perform actions? So then the point where the activity function came. So it is mainly called by the orchestrator function, and it's perform work and optionally return a value. So inside the activity functions, we can receive input data from the orchestrator function, and we can return data to the orchestrator function. So mainly then in our business scenarios, for an example, we can code our business logics inside these activity functions, and we can call them inside the orchestrator functions. Then you will get a question how these orchestrator functions call. So as in my first diagram, we can see that entry point to this process is client function. So this client function can be a HTTP trigger or time trigger. So it is a regular Azure function which starts an orchestrator function. So yeah, um, then let's move into Azure Durable Function application patterns. Here that there are function chaining pattern, and then fan out fan in method, then async HTTP API method, then the monitor pattern, and then human interaction, and the last one is aggregator. So let's see how these application patterns work. So the first one I'm going to explain is about function chaining. So a function chaining is a sequence of functions execute in a specific order. So it's like when the one is finished, then the output of that function is taken to the other function. So mainly it's a sequence of functions execute in specific order, and the output of one function is applied to the input of another function. Then the fan out fan in method, there we can execute multiple functions in parallel and then wait for all functions to finish. So in here we sync at a one point at a time. So this can be used in a scenarios like where we want to run some parallel process. Then the next one is async HTTP APIs. Uh, it uh, it is from this diagram you can see that there's a workflow. So in the middle there's a get status. So it's like again another trigger. So then it trigger, and so then it will come to the middle of the action and the process continues. So it's like they address the problem of coordinating the state of long running operations with the external clients. So this implement by having HTTP endpoint trigger the long running action, then redirecting the client status endpoint that the clients poll to learn when the operation is finished. And the next one, it is a monitor pattern. It is also that in here also the same thing happen like async HTTP APIs, but there's a difference. This having this is wait until certain conditions are met. So it's a not like async HTTP APIs. Monitor, it's a flexible recurring process in a workflow. So it polling out until a specific conditions are met, and use timer trigger to address the basic scenarios such as that for the it has static intervals where, and then without any outer events, it can continue its process. So mainly that in the async HTTP API, we are exposing an endpoint for an external client to the monitor. But when it comes to monitor, instead of exposing an endpoint for an external client to monitor, the long running monitor consumes an external endpoint, and then it waits for a state change. Okay, so uh, these durable functions support many languages. So these are some languages, especially they support TypeScript, JavaScript, Python, Java, .NET, and C Sharp. So to run a durable function, mainly we need to install in our our local environment Azure Functions core tool, then VS Code with the Azure Function extension, and then normally when we run in the local, it's better if we have a Azure storage emulator. So uh, uh, for me that I'm using Azure, right? Early there was there's Azure storage emulator. So because the state of function has to be stored in the somewhere, then we can use Azure Storage Explorer just to take a look behind. So what's happening behind what's happening behind these orchestrators, these activity functions, and process related to this. And the IDE I'm using is a Visual Studio Code. And the other main thing we need is an Azure subscription and the Azure storage account. And so for today's demo, I'm going to use TS. So in that case, I want Node.js installed inside my local environment. Uh, so in the mid of the webinar, I'm planning to do a small demo. So in here, I'm going to do a mock demo. So for an example, I took a web data scraping scenario. Actually, here that inside the code inside here that I'm not going to implement exact business logics, but just to show how this is happening. So in web data scraping scenarios, what we normally do is we scrape data from the selected website, and then we store them in our database. And then in most of the cases, we run another set of algorithms on the collected data depending on our requirements, and map those data according to our business purpose. So here that in this demo, so I named this demo that ScraperDurable function. And here we are going to use one orchestrator function which defines the workflow, then three activity functions. So as I mentioned, that scrape data activity and save data activity, and for analyze part, there's another activity. So let's move into demo. Wait a minute. I'll increase the size here. And with the F1, um, we can use Azure Functions create. So so here it is prompting that you must have a project to create a function. So I will pick the create new project. And so inside my file, so I'm using this empty folder which is web data scraping, which I created for this. So then it will prompt the select language. So as I mentioned, Azure Functions, Azure Durable Functions both provide many languages. So I'm currently gonna use TypeScript. So then it will prompt a template. So for now, I will skip for now. So and then we'll go with the current window. So this is the normal file structure we got. So it is quite similar to what we get in normal Node.js project. And here this host JSON. So it configure function host. So while running locally and while running in Azure, this is useful. And then the local settings.json, it maintains settings for the local run, and so we can store some variables there as well, and the others are similar to normal Node.js. As our scenario, the first thing we need to create is our starter function because it is entry to the project. Then to define the workflow, let's create a orchestrator, and then we can implement our business logic inside our activity functions. Use F1 Azure Functions create. So this is Azure function. This is the usage of Azure function extension in the VS Code. So again, I'll create Azure function create. So I'm planning to use a durable HTTP starter here. So this is to trigger our function, and I will name it. So name scraper starter. And authorization level, currently I will use anonymous. If we use a function, then you need to use the key to access this trigger. So currently I will use anonymous, and here it will auto generate what we want here. So we'll explain this later. So then I will create orchestrator function. So again, same thing, F1. Uh, right now we want durable function orchestrator. So the name for this orchestrator will be I'll use scraper in front of this, and yeah. So then it will create again index.ts generate, and I removed those comments, they were unnecessary at the moment. And here what we need to do is we can define the flow here. So mainly the flow what we gonna do. For now, let's uncomment this part. And so the very first thing we need to do is scrape data from the website, then saving data uh, into our DB, and the last thing we want to do is do our our analytics part. Okay, so I will remove unwanted comments here. Yeah. Inside the orchestrator, to invoke activity function, we need to use context dot here the context define complete function and with the df durable function, and then call activity. So in our case, according to that, scrape data activity. I will copy this. 3 save data activity, then analyze data activity. I'll use it analyze whatever. Okay, let's have the comments also. And now let's create our activity functions, 3 activity functions. So you should create functions, Azure function activity. So our first one is scrape data activity, and our second activity is save data activity, and the last one is analyze data activity. So in here I'm actually, so inside this activity you can perform any business logic. So I will use a template I'm having, so it will ease our work. Inside the scrape data, I return. I'm planning to return here, so then we can uh, demo that how the Azure Durable Function pattern chaining works. So in that case, I'm going to change a little bit our orchestrator. So it just we can declare a variable const add URLs. So then it's like this, and here we are getting cannot find this module. So in that case, the thing we need to do is we need to run npm install. It will take time, small time. And okay, now it's done. Yeah, so now all the things are over. So now you can view the folder structure. So we have 3 activities and 1 orchestrator, then the HTTP starter. So the entry point here is HTTP starter, and from that we are calling the orchestrator, and apart from that is function JSON, this showing uh, bindings and return types and name of the our orchestrator here. This is orchestrator client, and the name is starter. So here I will let's keep on the get method here. uh, yes, and when it comes to orchestrator also, it is different bindings here. So orchestrator, it is orchestration trigger, and here there's a direction and the context. Then for an activity, it is activity trigger. So that's all. So then the special advantage from these Azure functions, Azure Durable Functions, are that we can test, deploy everything in locally. So currently I'm going to run this locally. So for that I need to start my storage, my local storage. So yeah, so in that case we will get these .json files. So when uh, committing, you have to add this into git ignore, so then no issue. Yeah, so the storage started. So the to run this process, all I have to do is F5. So yeah. mm, yeah, the local emulator I'm using, and now the process is running, so I will increase the size. So our Azure function version is 4.0. So if you are using this for the first time, you will get to install core tools as well, but and to select the version. But since I'm using this for a long time, so I didn't got that prompt. And so here we can see that our URL, and then our three triggers and our orchestration trigger. Let's run the process and see how this is working using a Thunder client. Uh, I will reduce the size bit. Okay, to view all. And orchestrator name here is a ScraperDurable function orchestrator. So we can run. So this worked, and you can see then the scraper started. Then it calls to the durable function orchestrator, and from that its first task is scrape data activity. So the data scraping started. Then so here I got a small error. So here this when we test locally, so we are getting everything. So you can see that I got exception while executing save data activity. So it cannot read the property. So at URLs. So there's a small mistake I have done, because for this save data activity, we need to uh, we need to get this data. So that's function chaining. So we need to add that part. And yeah, now okay, so let's stop the here from this shift plus F5, or you can stop by in any way. So yeah, I will uh, rerun the process. So actually this is very useful. Even we can use debugging. So that's why I mentioned most of the things were easy here. Yeah, so I will call this starter again. Again, you can see the process starting data scraping. Um, when it is done, it is moving to save data activity. And yeah, now you can see that it was completed. So then it has completed calculating analytics. Okay, so inside our logs, you can see that our um, console log data should be here. Yeah, this saving. So you can see that our past URL is here. And here, this is the response we got when we uh, trigger our orchestrator function. So there are a few URIs here. So I will get the get URI, because we can even to check this, we can run everything even with the curl, also postman or anything. So since this get URI, I will show this in a browser as well. Yeah, so you can see that the name of our orchestrator, instance ID, it's a status. Since it is completed, you can see the complete state here, then the created last updated times as well. Let's move into deploying and publishing this into Azure. So create for that very first, what we need to do is create a function app. So when you move to our Azure extension, you can see that resources, workspaces, everything here. So I think with other episodes, you can further uh, get an understanding about this. So this is one of my early deployed one, but now we're gonna deploy our web data scraping local project into our Azure. So how to do that part is, so under the workspace here you have this deploy option. So it's very easy. So you can deploy to function app. So when you try to deploy, then it will show that already created resources. But here we need to create a separate resource. First, you need to create a function app in Azure. So for that, you need to create a resource. So here you can see the options. So for serverless, event-driven apps and automation, we have to use this option, create function app in Azure. So global unique name. So I will use um, AFG episode 3. So then it will prompt you to select a runtime stack. So I will pick Node.js, and then the location. So I will use what is default here. So here this will create in the function app. So it will take a small time. Here you got that function app created successfully. So in here you can view the resource. So under my resources, as I mentioned earlier, I had one. So this is AFG episode 3. So inside, when you expand this, you will be able to see the everything here, function settings, everything. So yeah, then the next step you have to do is deploy this function, our local function, into Azure. So for that, choose Azure icon here, and then go to the workspace area, and then select your project, and then simply you can do the deploy. So here you will get a deploy to function app. So this is not the function app created right now. The bottom one is the function app I created for this demo. So yes, then we will get that this will override any previous deployment and cannot be undone. So since this is first time, this is not applicable, but when it comes to second, third deploying, you need to keep track. So then by if you deploy anything, so it will override with the previous deployment. So yeah, I did deployment. So then it will build. When you go to this output window, so you can see how this is happening. So it is created inside AFG Wizard 3 resource group. So this is our app service plan name and everything. So yeah, here we got the deployment is successful as well. Yeah, so here the same thing. So you can, I will keep the orchestrator name and replace localhost. So you can get the status. So if you run this status query, you can get that still you can get that this is our orchestrator. So that's why I told that we need to use the correct name here because it will apply to our URL here. So yeah, you can see this runtime status is running, uh, created time, last updated time, everything. And yeah, because we have a small process, now it has completed. So let's go to Azure portal and see how it was there. I just restarted. So this is my resource group. So resource group I created for this is this. And so inside this, you can see there are 4 resources created here. So with the demo, I hope you got the complete understanding on how to develop, then publish, and then to deploy. And so how to do the testing, and then the monitoring part I didn't go further, but with the future episodes you can learn more about monitoring with the Azure App Insight here. So the last part where I ended is these resources created with the Azure Function app. So mainly this resource group is a logical container for related resources. And then the next thing it created was Azure Storage account, which maintains state and other information about the project. So, and the next thing is a function app. So it provides the environment for executing your function, and also the function app lets you group functions as a logical unit for easy management, deployment, and sharing of resources within the same hosting plan. And then for the hosting we have to use app service plan. And then last one is the application insight. So instead of so it is connected to our function app, and it track the usage of your functions mainly. uh yeah. So now here our next slide is about best practices for the Azure Functions. Here I have used Azure Functions because since Azure Durable Function is an extension of Azure Function, most of the best practices are similar. So in that case, the very first thing you need to do is choose the correct hosting plan, because it affects on performance, reliability, and the cost. And the next one is we need to configure storage correctly, because for functions host for operations such as managing triggers, and when it comes to logging executions, so we need to use the storage. So the configuring storage also one of the best practice we need to follow while using Azure Functions. And then the organizing your functions. So, and how you group your functions and function apps can impact the performance. So because with the grouping, so it mainly that it affects on the performance, scaling, configuration, deployment, and security of your overall solution. So as I mentioned that in the demo that I just show the simple deployment, but with the Azure DevOps and with there are further webinars in our series. So there you will get to know how to optimize these deployments. And then writing the robust functions is a one of another best practice we have to use. And the when designing, we need to consider about security, consistency, and we need to maximize the availability, and we need to when it comes to this as this is serverless, monitoring is another important part here. So especially with the app insights, so and there are a few other tools for serverless, so the monitoring part also one of the main thing we should consider when developing Azure functions and building redundancy. Mainly, why we need these durable functions? So these durable functions define workflow in the code, and we can understand entire picture of the workflow. So we do not require to analyze the multiple functions. So within the orchestrator, we can get an understanding about the workflow happening in our process. And with the durable functions, we can manage workflow states easily. And then when it comes to parallel running, so it is also those implementations can do easily, with these durable functions, because in the patterns also I explained that. And so you can perform scale out to bring the potential for the speed of the system. And then these durable functions, this can wait asynchronously for different external events during the execution process. So when we move to the next slide, so any idea about this event driven mechanism? So it is like using a trigger to communicate between decoupled service. So with the durable functions, it is your event driven mechanism. And then price model. So as the durable functions developed on top of the existing Azure function models, we can benefit from the serverless pricing model. So however, we need to pay for when our functions are running, but also that our orchestration function invocations will be rapid process to wake up and decide what's next step in the workflow to execute and go back to sleep mode until the next step is not completed. But you aren't built for any time spent awaiting or yielding in the orchestrator functions. So it's like pay for what we use only with these durable functions. And the other two things which makes us to use these durable functions is that as you saw in our demo, so we can easily do this developing testing entire flow in the local environment. And it is even we can deploy directly into the cloud in our local environment. So then after publishing also, we can use application insight integrations, which provide access to function app telemetries and logs. So this here I have summarized the pros with the durable function. So we have more control over a running workflow, and it pay only for what we use, as I mentioned with the Azure durable function billing. And so we can edit, build, and run functions on local development computer, and supporting various languages. It's also one of the pros with the durable functions. And the last thing is we can publish directly into the Azure. So yeah, that's all from my side. So is there any questions? So if you have any questions, add it into the chat. And yeah, that's all.
Yes, guys, if you have any question, you can ask.
When a function crashes, normally we can implement a few retries. So I will add the link. So inside the durable functions, we have a few retry options here. So yeah, I'll share the links here. So in that way that for an example, if for an simple scenario, so if you have 3 retries, so it mainly check normally what it doing is this durable functions uh, store their status. So when crashes, so with the we can have kind of a check status function inside here. So in that you can just check the status. So then it will manage to restart by itself. You can edit this time. So up to 10 minutes, you can uh, run without a timeout. You can change that actually. So that option is available. But there's a maximum level. I think it's with the plan. Yes. The question is, can we run any long polling functions? Yes, we can do that. In my project also, I'm doing such a scenario. So there, that the main way is the how you can manage this. So for these long polling functions, you can actually use this monitor pattern. So with the monitor pattern, so when one condition is until you can have some conditions, so until those are met, you can continue.
Okay, right. Actually, I would like to thank Nishara for accepting our invitation and taking a bit of time for her busy time from her busy time schedule, and sharing knowledge with us. Actually, yeah, you can join with us our new session, our next session, Asian Management Tool and Security Solution, and you can stay tuned with us by our social media and YouTube. You can get in touch with us, and that's all for this session actually, and thank you everyone. Hoping to see you all in next session. Thank you very much.